So welcome to the first lecture for nutrition and meal planning. So in this chapter, we really look at what makes up the science of nutrition. And we hear that word nutrition all the time. What does it mean? What do people think of? What words come to mind when they hear nutrition or think about studying nutrition? And the word diet is the largest on this word map. So, that's where a lot of people think. They think that, nutrition is all about weight loss, all about a specific diet. And I hope after this class you realize that that's not what it is. There's lots of things around nutrition that we look at. You can see some other words on here, healthful meals, fruit, you know, eating, slim, lots of words that people kind of think of when they hear nutrition, but it is a very complex science. So we're going to look at what that means. And if you read the first chapter in your ebook of this nutrition and the science and scope of nutrition chapter, you'll see that, read that first part about how we started to realize how big of an impact nutrition had during various parts of our lifespan. So that first story looks at the Dutch hunger winter, and again how they started to learn, and this was well after this had occurred, that the hunger and the famine that was happening during the 40s and how that affected women who were pregnant and their offspring later in life. And so, just read that story. I think it's interesting to think about how our nutrition at various points in our life may affect us down the road, etc. So, we're learning a lot more every day about nutrition, but it is a young, dynamic science, and what that just means that we're learning a lot more. There's still a lot of things that we don't know or we don't know all of, but it is such a complex science that incorporates lots of different things. So physiology, biochemistry, but you also have to look at psychology. Why do we eat the things we eat? So sociology, how does food affect our culture? Agriculture, how do we grow the food? And even as complex things as, certain vegetables grown in one part of the country may have different nutrients in the other part of the country based on soil. So there's lots of things. Nutrigenomics, really looking at how our genes and nutrients interact. All of those things make nutrition such a dynamic, complex science. And I like this infographic as well that really looks at, some things that nutrition is. So a lot of people may think of the bottom left one, the green one, the effects of food on health and disease risk, which is very important. And that's a big part of what we study, looking at if we eat more of this, does that mean we're less likely to have heart disease or whatever that specific diseases that we're looking at. And so that's an important part of it. We also identify those chemical components of food. So you see that resveratrol, which is that compound that people will talk about in red wine, but it's also in some other berries and things like that. And so we can look at that chemical component in the food, and then if you go below that, what effect does that chemical then have on the body? And so it's thought that resveratrol decreases inflammation. So you can kind of see how we can put those things together. But it is definitely a process to look at. And then also, I like the factors affecting availability and food choices. We can't study nutrition in a bubble. We can't come up with this just perfect diet. If you eat exactly this way, you'll live forever, which we all know is not true right now. But that's something when we have to we can't do that because we have to think about why do people eat what they eat. And it may vary. Some days you may eat more for health. Some days you may eat what you have access to. You're busy. We may live in an area where we have more access to certain foods than others. And so all of those things matter. And we can't study nutrition thoroughly without looking at all of those aspects of nutrition. So there are some diseases that may be caused or have an increased risk related to diet. And, I want to have a conversation about risk as well with that. This isn't certainly saying that, this is the end all be all, or that anyone who has, this certain diet will have this disease. We just look at risk. And so what this chart is looking at is the leading causes of death in the U.S., and so heart disease and cancer are the two top causes of death in the United States, followed by lower respiratory disease, accidents, stroke, Alzheimer's disease, diabetes, influenza and pneumonia-related diseases, kidney disease, and suicide. Those are the top 10 causes of death. And what they've done in this table is really just highlighted in red the top 5 that are significantly influenced by diet. And so we can see that heart disease and cancer may be definitely increased by the types of foods that we eat. Same thing with stroke. Alzheimer's disease is maybe a newer one for people to really make that connection, but we definitely see certain dietary patterns may decrease the risk of Alzheimer's disease, and diabetes as well. So again, we know there's disease, the cause of diseases is multifactorial. There's genetics, there's, your environmental exposure to things, there's exercise, there's diet, all of these things. So it's not just one thing that's going to cause any of these, but it's important to think about it from a big picture standpoint. So, what do we want to look at? And I'm sorry that cut off a little bit there, but really that's just looking at, certain dietary patterns, things that emphasize fruits and vegetables, whole grains, fish, those kind of things may have a decreased risk of certain chronic diseases and increased longevity. And certain foods that maybe, like diets that are lower in fruits and vegetables, have too much red and processed meats, all of those certain things may also increase our risk for certain diseases. And so again, this is a delicate system though. We'll talk more about this as the semester goes, but, I don't want you to feel like, one food is good and one food is bad. We've tried to get away from that a lot in nutrition recently. There's a lot of kind of vilification of foods, etc. And no one's saying, you have a cookie, all of a sudden you're all the way, in the super increased risk for all of these diseases. So we certainly don't want to paint that picture. And that's why really looking at overall dietary patterns is really important. Not saying, good or bad. You have a hamburger every once in a while, you really enjoy them, great. All of a sudden now you're, super high risk. That's not true. So I don't want you to, get that misconception from looking at an image like this. But we can look at, how can we increase certain foods in our diet, like fruits and vegetables that maybe help with our disease risk. What can we do to fit that in a realistic way, so still thinking about, the factors that influence our food choices, etc. And we'll talk more about that kind of thing as we move on throughout the semester as well. So let's look at nutrients and break that down a little bit. So these are chemical substances, and this is one of my pet peeves, is when people will talk about, like, I want my food without chemicals, and I'm kind of like, it's not possible. Even water's a chemical, right? And I understand a lot of times what people are meaning in that statement, but really, words matter, and how we talk in nutrition especially matters. It's important to be factual with what we say. And so, nutrients are chemical substances that are obtained from our food. We have essential nutrients that must be obtained through food, so our body cannot make those. So we break these down into macronutrients, those things we need large amounts of daily, like carbohydrates, protein, fat, and then water. We need a larger amount of water, so it's thrown into that as well. And then micronutrients, which are our vitamins and minerals, and we just need those in smaller amounts. And so we'll go through in the next couple of chapters, we'll look at macronutrients specifically, and then later on in the semester go into micronutrients. We'll talk about all of these in more detail, but this kind of just breaks down a little bit of the macronutrients. So again, our carbohydrates, and a lot of times when people think of carbs, they think of like bread and pasta, but a lot of foods contain some carbohydrates in there, so you can see some function that carbohydrates may play in our body. Our lipids, so again, our fats, and we'll talk a whole chapter about the different types of those. Those are important. They're a big part of the cell membrane. They are important for making hormones and other compounds. Our proteins, which are a major structural component of our cells in our body. And then water. Again, water does not give us any energy, so it doesn't provide any calories, but it is super important for our health as well. So we'll talk a little bit more about water later on in this semester. And then again, don't memorize all these right now. We're going to talk about all the vitamins and minerals later. But this just breaks it down a little bit for you. Some of those things we'll talk about. We need them in small amounts. They're important for a lot of the chemical reactions in our body. So we'll go through those in more detail, but this chapter is kind of just introducing to you what kind of things we may look at in the future. Let's talk about calories too. And sometimes we think of calories turned into this really bad word. Like calories are a bad thing for some reason in our culture. But really, it's a unit to measure the energy we get from food, and it's very important, right? We need energy. Energy is our capacity to do work, and so we need to have energy to do everything that we do. Our heart needs energy to beat. We need energy for our brain to function, for us to walk, around the block. All of those things require energy. I'm going to break down calorie a little bit more for you, and this gets a little complicated, so if you have some questions, refer back to your book or shoot me an email about this. So hopefully I don't confuse you too much. But calories with a capital C or kcal, and if you go back, I'll show you back here. If you're looking at this 4 calories per gram, 9 calories per gram, etc., what that's showing, and we'll talk more about that later. You see that kcal there? So that's the same thing as that big C calorie, is what we normally see on a label. Now this is kind of, if you're in physics or really into the science, you may talk more about these. That technically is equal to 1,000 little calories. We don't ever see this in real life, really. I say real life, meaning not in a lab or a kind of academic or scientific setting. So out on foods, whether someone spells calorie with a big C or little c, they really always normally mean the big C or the kilocalories. So like an apple would theoretically have 70,000 of the little c calories, but we never talk about it in that way, so we would always refer to it as the kcals or the big C calories. And again, that's what I'm saying, regardless of how it's really spelled out in the real world, you're never going to see it with that little c, and that would really only be for a research perspective. So again, don't let that confuse you. Hopefully it wouldn't. If you saw calories on something, you would know that 70,000 was ridiculous for an apple, and they were probably referring to little, so big C is what we always talk about. So sorry if that confused you more. I had some people who read that in the book and got confused before, so I try to explain it. It is a little bit of a confusing concept, and it really fits a very scientific niche where they would really even use that. But the big picture to know from this is that calories are how we use or how we measure energy from food. So, that apple that I'm getting 70 calories from, that is a unit of energy, so my body is getting that much energy to use to function through that. So again, not being afraid of calories is very important. We need them, and we'll talk more about that as we move on as well. And when you think of malnutrition, a lot of people probably think of undernutrition, and it can be. Mal means bad. It could be undernutrition, it could be overnutrition, so you could be getting too much or not enough, unbalanced intake of essential nutrients and or calories. Someone could have enough calories, someone could have enough food and overall, but they could have a micronutrient deficiency because they're not getting the right types of foods and things like that. So there's lots of ways that we could have malnutrition. And again, we'll talk about several diseases, and even when we get into vitamins and minerals, we'll talk about what happens if you have too much or too little of certain vitamins and minerals. So hold on to that thought, but we will move forward with that in the future. And I want to spend a little bit of time looking at these dietary reference intakes. And again, I would encourage you to make sure you read through this part in your book as well. But the dietary reference intakes is really giving us an idea of what we need of certain nutrients. These are based on overall healthy population. Again, knowing that it's an estimate, we all have different needs. But they use these to try to give us kind of a goal of, how much vitamin C do I even need? How much fiber do I even need? So that's what they're doing here. So let me go through the top box for you. So I'm actually going to start at the estimated average requirement in the middle. And this will make sense in a second. So the estimated average requirement, let's say I have vitamin C, and I have research, I have biomarkers, so I can really make a good estimate of how much vitamin C will the average person need. So, if I say 1,000 milligrams of whatever vitamin I'm talking about, that'll meet the need of about 50% of the people. Why we don't use this amount is that's great, but if I said, all right, 1,000 milligrams, everyone eat it, and it only met the needs of the 50% of the people, and 50% of the people needed more than that, that's not a great recommendation to make. So what we do with that is go up to that recommended dietary allowance, and so we'll take that estimated average requirement. I've got the data to say here's about what the most people or half the people need. This is the kind of the average in here. And then I use some math to get 2 standard deviations away from that. And so really what the recommended dietary allowance is meeting the needs of almost all, so it's about 98% of individuals. So that's what we use. So they're related, so you have the estimated average requirement, and then we take 2 standard deviations from that math. And basically it's just a way to figure out, all right, we'll look at this, instead of just giving this number that meets the needs of half the people, we're going to try to give a recommendation number that meets the needs of about 98% of the population. There may be a couple people who, 2% who need a little bit more than that, but if most people are consuming this amount of the nutrient, they should be meeting their needs. We then have adequate intake, and when we'll use adequate intake is when we don't have enough information to develop that EDR, EAR, and RDA. And so again, if I don't have all the research data and the biomarkers to really give a confident estimated average requirement, then what I can do is look at a healthy population, see what most of them are consuming, and make a best estimate of what the amount I think is that's adequate for most people to take in. So again, it's aiming for the same concept as the RDA. We just don't have quite as much information about that particular nutrient to make an RDA. And this will change. So sometimes we've started out with adequate intakes for a certain nutrient, and then science advances and we're able to transition that adequate intake into an RDA with more information that we have. So you'll see one of those for our nutrients. The last thing on here, the upper limit, this is also really important to talk about, and some nutrients have these and some don't, just depending on toxicity risk. But what this is the highest level of daily nutrient intake that's unlikely to cause adverse effects for most people. So, if you exceed this, then you're more likely to have unhealthy side effects from that particular nutrient. So, some of our vitamins and minerals may have toxic effects in high doses, and so some of them do have this upper limit set saying, don't regularly consume over this amount of that nutrient. And then the bottom 2, we look at acceptable macronutrient distribution range, and we'll look at these when we get into our carbs, fats, and proteins chapter. But this is those intake ranges that's really consistent with good health. So they'll look at overall health and say, about 20 to 35% of your diet, for example, should come from fat. And so that's where they use those acceptable macronutrient distribution ranges. So again, you'll get into each one of those in the carb, fat, and protein chapter. And then the estimated energy requirement is the average energy intake. And so if you've ever had something where you put in like your height, weight, gender, age, activity level, and it spit out a number of how many calories you needed a day, that's what this estimated energy requirement is. But a couple things to note on this is that 50% of individuals will have higher or lower energy needs than this value. And so, it's just an estimate. And so I really like that your book kind of says, yeah, you can get that number, and there are tons of formulas. You can put all those things in and it will spit out that number, but it's really just kind of an initial idea, initial goal. Again, our calorie needs are going to vary person to person, and so, we can't just say everyone who's the same age, gender, height, weight, activity level have the exact same calorie needs, because that's not true. We're all different. So it is just an estimate, and I think that's important to look at, and we'll talk more about that when we get into the diets and things later, because some people take that as the end-all be-all and then learn to ignore their hunger cues from that, and really, it's just an estimate. We can't give it more power than it has or deserves. And so, when people use those goals that are generated in terms of calorie needs and take it, to the calorie and stress themselves out over only eating exactly that amount of calories, that can kind of be detrimental to health and may not truly reflect what their individual needs are. So keep that in the back of your head. We'll talk more about that later as well. This gives a really great image. I like this a lot of what we're looking at in terms of where those EAR, RDA, adequate intakes fall, etc. And this also looks at the risk of adverse effects compared to the nutrient intake. So on the bottom, you'll see, and this is just a generic nutrient, but low to high of nutrient intake, and then the risk of adverse effects. And it makes sense that, in really low nutrient intake, so very low intake of a certain nutrient, your risk of adverse effects, that black curve, is going to be pretty high. Then the closer you get to that RDA, the risk of having inadequacy or not having enough of that is going to be pretty low. So you can see in that moderate range of nutrient intake, the risk of having any inadequacy or toxicity or adverse effects in general is pretty low, almost zero. And then as we go past that upper limit, again, we see an increasing risk in toxicity or adverse effects as well. So this is really showing you that too little or too much of a nutrient can have a higher risk of adverse effects. So it's really kind of the Goldilocks, analogy here that, not too little, not too much, just right. And that's really important concept to remember in nutrition. I think some people have that more is better approach with vitamins and minerals, and I see that all the time. If this is what's recommended, clearly if I take 3 times that, I'm going to be better off. And that's not necessarily true, and that could actually be harmful. And so we definitely just have to think about that and not have that the more the better approach. So keep the Goldilocks analogy in the back of your mind as well with that. I want to briefly talk about the scientific method because this is important to understand when you're trying to answer questions and how do scientists figure this out. And I hear a lot of people talking about not just nutrition but health or other things that they may have no education or exposure in, and they're people always say, I did my research and I found this, but what does that mean? What are they meaning when they're doing research? Are they truly doing research, or are they just reading a few articles on Google? And do they understand the basics of that subject to really truly even be able to understand the research that's been done on a specific topic? And do they understand how studies are designed and all of that kind of stuff? And so it is a lot more complex when we have a question we want to know the answer to than reading a few articles that pop up on Facebook. So there are several steps in here: doing background research, so seeing what's already been done, developing a hypothesis or educated guess, designing an experiment, gathering data, interpreting that data, publishing results, and normally, the frustrating thing about the scientific method, or great thing, is normally when you finish answering the question, you have you started with one question, you did a study, and now you have 5 new questions at the end of it. And so that can be a great way to look at it. But this breaks this down a little bit more. You can look at this in your ebook as well. But observation's that first step. So then you're going to look at what questions we can make. What's our hypothesis? How is that experiment designed? What are the results? What are new questions? All of those things, go hand in hand with each other. And I like this theory versus hypothesis they talk about here. You really need a lot of similar studies to be consistent to really say this hypothesis is a theory, or we're really going with it. We're going to propose that we have enough evidence to change our minds on something, and that can really never be done with just one study. And so a lot of times in research, you'll see scientists and experts in the field, making, here's what I found in my study, but before we make further conclusions, we need to do X, Y, and Z. And so there's a lot of testing that's done, especially in medicine and health. So some types of nutrition studies that we can see are randomized controlled trial. And so this could be a situation where subjects are either assigned to a control group or a treatment group. The control group may receive a placebo, which is a fake treatment, or even, it could be just a standard treatment. Sometimes in nutrition and health we'll do that. This first group just gets what the current standard treatment for this disease or condition or whatever we're looking at is right then. And then the kind of treatment group may get something new or different, and we're trying to see is this new medicine better than the current medicine? And so they'll compare those two things to each other. A placebo effect is that apparent effect experienced by response to fake treatment. And the placebo effect is real. So, it could be, I'm taking this diet pill, and so I, feel like I eat healthier, and so I feel better, and so I think I'm, having better luck with sticking to this nutrition plan or whatever it is. And so it is a real thing. Patients may take a pill and think it's going to work, and it may actually reduce their symptoms. And so that's kind of a randomized control trial we'll do. There's also a lot of epidemiological studies that's done, and those are really observational studies. So we can look at variables in a population. And, one thing to remember is this just gives correlation. So correlation does not equal causation. So there's a lot of things that, have been, debunked from this, but, and there are a lot of things that are related, and I'll put some up for you guys on something, but, there's even one that looks at things with like deaths and ice cream sales or heat, and there's just a lot of interesting articles on that I'll share with you as well. But basically it's really, I can see that, more people who smoke are getting lung cancer. And I can do a kind of retrospective or prospective study on this. And so let's say, I'm trying to get some more evidence. And again, it's not necessarily proven, but we can combine epidemiological data with other data. And I can say, all right, I'm going to follow, I'm going to interview, 100,000 people who are 70 years old about whether they smoked or not and about whether they ever developed lung cancer. And so that's something where then I can look at the variables, and maybe I can say that, there were, of the 50,000 who, never smoked, much smaller percentage of them got lung cancer than of the half of my group that did smoke. And so there's other things like that we can do in that epidemiological study. And an experimental model system kind of takes really our lab cell culture studies, our animal studies, all of those things, and learns more about how nutrients affect our disease, our physiological processes, all of that kind of thing as well. And again, with animal studies, we can't necessarily directly correlate something that happened in an animal to exactly how humans would respond to that nutrient, etc. So this just breaks that down into more visual representation, if that's helpful. So look over this as well. Also looking at this mice study, and we talked about the Dutch famine study, so again, make sure you read that. And your book also talks about the Waterlands mice, and so I wanted to break that down a little bit for you, but again, please read about that in the book. So the question in Waterlands mice study was, does diet and pregnancy change the baby's coat color? And the hypothesis was that supplementing the diet in pregnant mice will affect the baby's coat color and health. So that's what they thought would happen. And so again, you can read more about that in your book as well. And they fed some mice a supplemented diet and others a regular healthy diet and recorded the fur color of babies. And they found that the mice that were fed a supplemented diet were more likely to have babies with brown fur. So that's kind of how they went through. They had their hypothesis, they designed their experiment, they interpreted their data, and then they published their findings. So just kind of wanted to walk you through what that might look like as well. So where do you find nutrition information in your everyday life? And, I've asked this question of lots of people, and there's lots of things. It's all over the internet. All the magazines seem to have the new hottest diet when you're in the checkout line. TV, radio ads. I've seen signs on the side of the road. I've seen, friends and family, and you have no idea how, frustrating sometimes it can be for us dietitians when, we'll have someone come in and, they had gotten some good information from a health professional, and then well, they're friends and family, or, it's my neighbor's aunt, sister, or someone, said this. And so while a lot of times people are well-meaning, the overwhelming amount of nutrition information, and a lot of it false, can be very hard to navigate. And so we definitely recognize the difficulty that that can be, and want to talk about, what are some reliable information. And so registered dietitians is one group that has proven, so to get the registered dietitian credential, you have to have at least a bachelor's degree, an internship that's at least 1,000 to 1,200 hours, and pass a comprehensive board exam after all of that. So, proven that they have passed the test, the education, the experience to give that information. There are other professionals who may have degrees in the field as well. There may be other health professionals who have significant continuing education training in nutrition. So this is one thing I caution. Just because someone's a nurse or even a physician doesn't mean that they've had a lot of training in nutrition. And so, just be careful, on that with health professionals, what that may look like in terms of the information that they give out as well. And just some quick red flags for nutrition information. And I see this all the time, and we'll talk more about this later in the chapter as well. But, sometimes we see nutrition information accompanied by someone trying to sell you a product, a tea or a cleanse or something like that. And so, again, you have to be a little skeptical of their motives. Also, scare tactics is something that's really bad. If you don't follow this, or, I see these all the time on, like, the little advertisements on the internet, never eat these foods or your, digestive system will rot, or whatever they're trying to scare you into at that point. If they have testimonials as the only evidence of effectiveness, and I see this a lot too, and testimonials are fine, so-and-so had a good experience with this product, whatever, but that can't be the only evidence that this product works. There needs to be other studies and things like that. And again, that goes to the bottom line. If the recommendations are just from one study as well, we have to also look at who paid for that study, all kinds of things. If something sounds too good to be true, it normally is. If there's no author listed on claims, that's a big thing as well. You can't evaluate, who is this author? Do they have any credentials? Are they an educated health professional? If they make negative claims against health professionals, that's also a really big red flag. And the quick results, all of those things are things we want to look out for. So we will talk more about all of these things as we move on throughout the semester, but this is a great overview of what you can expect to see throughout this book and this semester. And lastly, before we end for today's lecture, thinking about the U.S. diet, and some things that we think about nutrition in this country is a lot of Americans aren't consuming enough vegetables. They may be consuming too many empty calories or things from solid fats, added sugars, refined starches, and they may consume too much salt on there. And so you'll learn a little bit more about me and my philosophy, and I'm not a dietitian, and most of us aren't, to say, never have any of these things. We know salt is a vital nutrient. We'll talk about that. You need it. But again, it's one of those, are we having too little, too much, all that kind of thing. And same thing, it's not that we can't ever eat added sugars, but can we limit them in our diet, or, make our diet more of our fruits and vegetables and things like that. So we'll talk more about that as we move forward. Thanks, guys.